Good morning, students, and welcome to our today's class. Today, we want to consider with you very two important aspects of the measurement of a data set or distribution of a data called skewness and Q26. Do remember that in statistics, we have different measures. For instance, we have what we call measures of central tendency. In the measures of central tendency, the interest is to measure the center of the data set or the center of the distribution from where the data was obtained. And in the measures of central tendency, we talk more on the mean, the median, and then the mode. We equally have another measure called measures of what? Of dispersion. In the measures of dispersion, the interest is to measure how far apart the observations are from each other, or how the observations are far from the mean of the observations. And of course, in the measure of dispersion, we talk more on the variance, the standard deviation, the range, and then the mean deviations and the rest of them. But today, we are looking at another measure. And this measure is called the measures of what? Of shape. And then the two measures of shape we have in statistics are the skewness and what? And kurtosis. The question becomes, what do they do? What do they help us to do? These are two important aspects of measures that equally help us to describe the shape of a data set or describe the shape of the distribution from where the observations were what were drawn. That's what we call skewness and what? And the kurtosis. So if they ask, what are the two measures of what? Of shape. The two measures of shapes are skewness and what? And the kurtosis. So we now begin by looking at what we call the what? The skewness, or what we call the skewness. Sorry. What is skewness? Of course, skewness measures what we call lack of symmetry or the extent of departure from symmetry. That is what skewness does. I write. I say skewness. We are beginning with skewness. With skewness. I say skewness. It measures lack of symmetry. Lack of symmetry. Lack of symmetry. Or the extent of departure from symmetry. Or the extent of departure from symmetry. That is exactly what skewness does. It measures lack of symmetry, or it measures the extent of departure from symmetry. So the question becomes here, what is symmetry? For us to even understand what actually skewness is, what is measuring. So we begin by looking at symmetry. We are looking at what? At symmetry. Symmetry. A distribution is said to be symmetrical if and only if the right-hand side of the data set or the distribution is the same or familiar with the left-hand side of the data or of the distribution. That is only when we say that a distribution is symmetrical. I repeat, a distribution is said to be symmetrical if and only if the right-hand side, the right-hand side of the distribution, permit me to write this as a distribution. The right hand of what? Of the distribution is the same, or familiar with the left hand side of the distribution. The left hand side of the distribution. Of the distribution. That is when we say that a distribution is symmetrical. when the right hand side, or what we call the right tail of the distribution, is familiar or is similar with the left hand tail or the left tail of what of the distribution, we say that that data set or that distribution is symmetrical. Now, what happens when this condition is satisfied by a distribution? That is, what happens when a distribution is symmetrical? The following are the conditions that we see when a distribution is symmetrical. Number one of the condition. Number one, the mean or the mode, the mean and the median of the distribution are equal or approximately equal. But for now, let us be using the word equal. I repeat, if this condition is satisfied, it implies the distribution we are discussing or the data set we are discussing is symmetrical. If the distribution or the data set is symmetrical, what do we look forward to see in the behavior of that distribution or in the behavior of that data set? Number one condition we look forward to see that the mode, the median, the mode, the mean, and the median of that data set or that distribution are equal or approximately equal. That's number one. Number two, that happens. The measure of skewness in such distribution or data set is zero. The measure of skewness in that data set or distribution is zero. What do we mean by this? We are saying that when a data set is symmetrical or the distribution is symmetrical, that when we compute the value of the skewness from such a data set or distribution, the value we are going to get is what is zero. Then the third thing that is going to happen here, the third thing that will happen here, number three, is that the third normalized moment of that data set or distribution is zero or approximately zero. The third normalized moment about the mean from that data set or in that distribution is zero or approximately zero. So anytime from our data set or from distribution, these conditions are satisfied, the quick conclusion we are going to arrive at is that the data set or the distribution which we are dealing with are symmetrical. Number one, when we calculate the mode, calculate the mean, and calculate the median from that data set, and all of them are equal, we quickly conclude that then we hold it number one. Number two, we now calculate the measure of that skewness using the formula of the skewness, which we are about to come to. If the answer turns out to be what? To be zero, we now talk about the third normalized moment. If the third normalized moment, of course, equally becomes what? Zero, we conclusively conclude that the distribution or the data set is symmetrical. And again, I have to point it out. You might check the first condition. If the first condition is true, the pointer is that the distribution of the data set you are dealing with is equally symmetrical. The same thing applies when you check the second condition. So it mustn't necessarily be that you have to exhaust all the three conditions before you can arrive at that conclusion. Once one is satisfied, it implies that the distribution or the data set you are dealing with is symmetrical. And of course, most of the time, normal distribution is a symmetrical distribution. So we now come. What if this condition is not satisfied? That is to say, that the distribution we are dealing with is not symmetrical. What do we look forward to see from that data set or from that observation? So permit me to clean the board now, while we now go into that what we are going to see when this condition is not satisfied and we are saying that our data set or our distribution is not symmetrical. Look at the conditions we are going to see. So permit me to clean here. When the data set or when the distribution is not symmetrical, look at what we are going to see. Number one, the mean, or let me begin the way I wrote the other one, the mode, the mean, and the median are different. Are what? Different. So the value of the mode is different from the value of the mean, which equally is different from the value of the median. This is a condition we arrive at when the distribution we have is not symmetrical. Number two, the measure of skewness is not equal to 0. The measure of skewness, skewness is not equal to 0. And if it is not equal to 0, it implies that it can be greater than 0 or it can be less than 0. So we equally look at when it becomes greater than 0, what do we have to say? When it becomes less than 0, what do we have to say? So, but we are coming to that. Let us look at the third condition that is going to happen. Number 3. We say that the third normalized moment, the third normalized moment about the mean of the data set, or distribution is 0 or is equal to 0. When these conditions or any of the conditions is satisfied, our conclusion should be that the data we are having at hand is not symmetrical. That's what we are going to conclude. Like we had the 3 conditions when our data sets or distribution is symmetrical. Here equally are the 3 conditions that we see when our data set or distribution is not symmetrical. Then we now come to this particular number 2, where we say that the skewness is not equal to 0. So we are going to look at it as 2 conditions. What happens when the skewness is greater than 0? What happens when the skewness measure is what is less than 0? So we start with the first one, the first condition. Let me call it I. This I is here now. When skewness is greater than what? 0. When skewness is greater than 0. Greater than 0. So we are going to see what are those things that happen or that we look forward to see from our data set when the measure of skewness is greater than 0. what we are going to see is this. We have, that is number what? Our I, or let me call it what? Our A here. We say that the mean of the observation, we say the mode is less than the what? The median, which is less than the what? The mean. So when the measure of skewness is greater than 0, we look forward to see from our data sets that when you calculate your mode, calculate your median, and calculate your mean, you will eventually find out that your mode is greater than median, which in turn is greater than what? At the what? The mean. What other thing do we see there, which is B? We now say the distribution is skewed to the right, is skewed to the right. This right is where the emphasis is. The distribution is skewed to the what? To the right. That is the second thing that happens there. What is third thing that happens there? This number 2 or number B simply means that the distribution has a longer tail in the right. The distribution has a longer tail to the right. That's what it means. So any day you calculate your measure of skewness and your measure of skewness is greater than 0, these are the likely things or the things you are going to observe from your data set or from your distribution. That the mode is less than the median, which equally is less than what the mean. And then the distribution is said to be skewed to the what? To the right. And if the distribution is skewed to the right, it implies that it has a longer tail to the right. We are actually going to show this thing diagrammatically to ensure that the knowledge which we are trying to pass is actually passed very well. So we now talk about, what if we now measure the skewness and then the value of skewness is less than what? 0? What happens? So please permit me now to clean here while we now talk on the likely things that are going to happen when the measure of our skewness is less than 0. Permit me to clean here. Okay. I'm now calling this one I because I talked about I when I said when the measure of skewness is greater than 0. This time around, when the measure of skewness is less than 0. Less than 0. What happens? Number A of what happens is this. Okay? That in this condition, we are going to see that our mean is less than what? The median, which is less than the what? The mode. Do remember that in the first one, when the skewness was greater than 0, what we had is that the mode is less than the median, which is less than the what? The mean. But we are saying that when the measure of skewness becomes less than 0, that our mean becomes less than the median, which in turn becomes less than the what? The mode. We are going to show this thing diagrammatically so that you are able to understand what we are saying more. Number B condition. We are going to say that the distribution is skewed to the left. The distribution is skewed to the left. Is skewed to the left. The number C thing there is, if the distribution is skewed to the left, the implication is that the distribution has a longer tail to the left. The distribution has a longer tail to the left. It has a longer tail to the left. So these are the conditions you are going to see when the measure of skewness is less than what? 0. Okay? So you are going to permit me to clean here. When I clean here, we try to show with the diagrams what we mean by skew to the right and skew to the left and the rest of them. So permit me to clean here. Permit me to clean this place. Okay. So the first condition says when our distribution, the measure of skewness is greater than 0. Then the distribution has a longer tail to the right. Let us show it with a diagram here. Then I have, let us call this a distribution. This is my distribution. This line here is my distribution. It begins from here and it ends here. That's my distribution. Let me equally have another distribution that begins from here and ends here. And then I finally have a third distribution that begins from here and ends this place. Then I have something like this. Look at me draw. I have something like this. If you watch, in this distribution which I have drawn here, it has a longer tail to the right. This is the right of the distribution. This is the left of the distribution. So you now come here and locate this place. This place which you located that agrees or coincides with the highest peak of this distribution is of course where we call the mode. Where we call the what? The mode. So this place is called the mode. This is the mode. And remember that if from here to here is the distribution, the center of this distribution should be regarded as the median of that distribution. So if you look from here to here and we plan to divide it into 2 equal halves, you find out that somewhere here should be dividing this distribution into 2 equal halves. And in that case, this particular point now becomes what we call the median. What we call the what? Median. So here now becomes what we call the median. The median. Another thing here is the mode, here is the median. When we talk about what the mean, we are saying add up all the observations and divide with the number of the observations. Here, there is a longer tail in the right, and this longer tail has, of course, more observations. So when you sum all of them and divide, there is every probability. Here is, of course, my median. There is every probability that the mean will lie somewhere here. So I will now have that here becomes what we call the mean. And then, of course, you know that here is what we call that skewness here. Skewness is greater than what? 0 here. And of course, when this skewness here is greater than 0, the implication here is that the distribution has a longer tail in the right, which is here. And then you find out that the mode is less than the median, which is less than the what? The mean. Then I come to this one. Look at me draw. I'll have something like this. I have something like this. I have something like this. Permit me to just have it drawn this way. Now, if you want this one which I've drawn here, you find out that if I draw from this peak, it comes down here. Here becomes my mode as usual. The point that agrees with the highest peak of the distribution. And like I had earlier said, when we talk about the median, the center of the distribution, we divide this line into two equal halves. And that becomes the mark of what of the median. It will be somewhere here, even though with my free hand, it will be somewhere here. Then we have something of this kind. Here becomes what? My median. This becomes my median. And then when we add up all the observations, remember more of the observations are smaller, which lies, more of them lies at the left. So when you add all of them and divide, our mean will be somewhere. Here is my mode, here is what my median. So my mean will be somewhere here. My mean will be somewhere here. Here becomes my mean. And you find out that when the distribution is skewed to the left, it has a longer tail to the left. This is skewed to the right. This is skewed to the right. This is skewed to the left. Skewed to the left. You find out that when distribution is skewed to the right, you find out that the measure of skewness should be greater than 0. That the mode should be less than the median. And the median should be less than the what the mean. But when the distribution is skewed to the what to the left, you find out that my skewness, the measure of my skewness is less than what? 0. And then my mean becomes less than the median, which becomes less than what the mode. Now, what happens now when the distribution is symmetrical? It is neither skewed to the right nor skewed to the what to the left. You are going to see something like this. Watch me draw. You see something like this. You see something like this. So that you now have that the center here is what we call the mode as usual. If you equally want to locate the median, which is dividing this into 2, it is equally going to agree here that here is the median. And what I have at the left and what I have at the right is expected to be equal. So when you sum all of them and divide, the mean will equally lie at the center. So you find out that in a symmetrical distribution, the mode is equal to the median, and the median is equal to the mean. These are the characteristics that we likely see, not likely see, that we see when a distribution is symmetrical. We want to believe that you have understood what we said about this, and understood what we said about this. Now, remember that we say that when the distribution is symmetrical, the measure of skewness is what? Is 0. So here, my skewness is 0. Skewness is equal to 0. So they might be asking you, when the skewness is greater than 0, what do we see in a distribution? Mode less than median less than what? Mean. Distribution skewed to the what? To the right. When the measure of skewness is less than 0, what do we see from the distribution? Mean less than median, median less than what? Mode. Distribution skewed to the what? To the right. When the measure of skewness is 0, what do we see from a distribution? That the mode is equal to the median. And then the median is equal to the what? To the mean. Then we now say that the distribution is normal. The distribution is normal. So another way of asking you this is, in a normal distribution, what is the condition of the mode, the mean, and then the median? They are all equal. So that's what we mean by that diagram. So we are now going to go into trying to obtain the measure of skewness from a data set. That is by giving you now the formula of the skewness from samples of observations. We didn't mention about the third normalized moment. We have had a class on moment, elaborate class on moment, that actually extracted much about moment. So we encourage you that you might also have to watch that class on YouTube that is tagged moment, to have enough background on how we are going to go about computing skewness using the idea of that moment. So permit me now to clean here. Okay. So we are now talking about the skewness. So measure of the skewness. So measure of the skewness, or let me just write skewness. From data sets. Okay, skewness from data set, permit me to write S subscript K as skewness. Okay, so this is equals. We have sum over the range of x of what? We have of x minus x bar all raised to power what? 3 all over. We have n multiplied by s raised to power what? 3. We now say where s, where s, where s equals standard deviation. Standard deviation. Standard deviation. So when they ask you to calculate from a data set the measure of skewness, it is sum over the range of x, open a bracket, x minus x bar, all raised to power 3, all over n multiplied by s raised to power 3. Where this s that stands here is the standard deviation. Now there is something I want to show you for you to know why some people go straight to tell you that the third moment is the same thing as skewness. This formula which I wrote for you here, if it is written this way, that m subscript to what? 3, which is actually what we call a third moment. That was why I made a reference to that class that we did on moment. Is given as sum over the range of x minus x bar all raised to power 3 all over what? N. The only difference between this and this is that in the denominator we have s raised to power 3. And it is because of the presence of this s raised to power 3 that we call this quantity normalized third moment about the mean. That word normalized. So people can go straight and tell you that the third moment about the mean is skewness. They are right. Some other person can tell you that the third normalized moment about the mean is moment. They are equally right. We use this formula when the observations we have is a large observation. That's the reason why you see me writing all over n. What if now the observation I have is small? If we have a small observation now, our formula is going to be that my s subscript k is going to be sum over the range of x. We have x minus x bar all raised to power 3 all over n minus 1 all multiplied by s raised to power 3. Okay? And in that case, this my third moment now is now going to be that my m subscript what 3 is given as sum over the range of x minus x bar all raised to power what 3 all over n minus 1. These conditions of n minus 1, they can only be used when n is small. And when n is small, we are saying here our n is greater than or equal to 30. Here, our n is greater than or equal to what? 30. But in this case, our n is strictly less than 30. N is less than 30. And here, strictly my n is less than what? 30. So these are the different kinds of formulas that we are to use when our sample size is large to the extent that it is greater than or equal to 30, and when it is small to the extent that it is strictly less than 30. These are the different formulas that we use there. Okay? So this is the formula for the skewness, measure of skewness. This is the formula for measure of skewness. So you permit me to quickly wipe here down. Let us take one question and solve. So let us be fast to manage the size of the video. Okay. All right. So the question I have here says, and I write, the question I have here says, is example 1, is example 1, example 1. Look at the data set. The data set is this way. Look at the data set. Okay. So here is my x, here is my f. So I have this way. This is 1, this is 2, this is 3, this is 4, and this is 5. The number of times that 1 occurred is 2. Number of times that 2 occurred is 1. Here is 3, here is 1, here is 2. The question says, obtain the measure of skewness from the data set. Obtain the measure of skewness from the data set. That's just the question which they ask us there. So we are going to work out this thing together with you. We first of all begin with solution. This is my solution. I have my solution. The solution begins by writing the formula of the skewness so that you know where you are going to. So we have that our s subscript k is given as sum over the range of x of what? X minus x bar all raised to power 3 all over n minus 1 all multiplied by s raised to power 3. This formula which I wrote for here doesn't contain anything about frequency. But unfortunately, from our data set here, they have given us what? Frequency. So we need to factor in the idea of frequency in this formula. And factoring it in here becomes that this is going to be, that this is sum, here becomes sum over the range of x of f of x minus x bar all raised to power 3 all over n minus 1 multiplied by s raised to power 3. The formula becomes this way. So we now go ahead now to solve. So we now have our table. This column here is talking about column for x. This is my column for x. So I have a line. So this is my column for what? For f, frequency. The x here is what? I have here to be 1. Here I have to be 2. Here I have 3. Here I have 4. Here I have 5. So under frequency here is 2. Frequency here is 1. Frequency here is 3, frequency here is 1, and frequency here is what? Is 2. That's what I have. Then I have this. I want to first of all go and get the mean, which is the x bar. So I want to talk about fx. Fx means we are using the frequency to multiply the what? The variable, which is this one here. So we have 1 times 2 will give me 2. 2 times 1 will give me 2. 3 times 3 will 9. 4 times 1 is what? 4. And then 5 times 2 will give me 10. Then I have something like this. Okay? Then I will now come under here. Let me sum them. Summing this frequency, 1 to 2 is 3. To 3 is 6. To this is what? 7. And to this is what? Is 9. So here is 9. Summing this one, this is 4. This is 8. This should be 17. This 10 here will make it what? 27. So if I want to get the mean, I will say therefore that my x bar is given as sum of fx all over sum of f. You remember the formula for what? For mean. This becomes sum of fx has given me 27, so I have 27 all over. Sum of f have given me what? 9. So it's 27 over 9, which gives me what? 3. So that now the mean is what? Is 3. Then I will now come back here. What I'm now going to have, I'm going to have a column that talks about x minus x bar. I'll close it and I'll have a line. My x is each of these observations here. My x bar is this mean which I've computed here, and it is 3. So I quickly come here, and here is my x, which is 1. So I will say 1 minus 3 will give me minus 2. Here it becomes 2. 2 minus this my 3 here will give me minus 1. Here is 3. 3 minus this 3 will give me 0. Here is 4. 4 minus 3 will give me 1. Here is 5. 5 minus 3 will give me what? 2. This becomes this. Okay? But if you look at what I have here, it is either raised to power 3. When I want to calculate the variance, it is raised to power 2. So I will now come and include a column that talks about f into x minus x bar, all raised to power what? 2. First of all, I will do this. This my x minus x bar has been gotten here to be minus 2. We are raising it to power what? 2, which is minus 2 raised to power 2, which will give me 4. Look at the frequency here, which is multiplying it. Here is my 2. 2 times what? 4 will give me what? 8. Here is my 1. 1 raised to power 2 will give me 1. Multiplied by this frequency will give me what? 1. Here is my 0. 0 raised to power 2 is 0. Multiplied by this frequency 3 will give me what? 0. Here is my 1. 1 raised to power 2 is 1. Multiplied by this frequency will give me what? 1. Here is my what? My 2. 2 raised to power 2 here will give me what? 4. 4 multiplied by 2 here will give me what? 8. So I have 8. I will extend this. If you sum this to this will give me 9. This will give me 10, and this will give me what? 18. So this is my 18. And you remember that when you want to calculate the variance, you find out that my variance, which is this s here, my s squared here, s squared is given as sum over the range of x of what? F of x minus x bar, all raised to power 2, all over what? N minus 1. This is the formula for variance. You should not forget this. Now we have gotten this numerator, that the numerator is 18. So I will say therefore that my s squared is given as, the whole of this numerator is 18 all over. My sample size is 5, of course. 1, 2, 3, 4, 5. 5 minus 1 is going to give me 4. So I have 18 all over 4. And this will give me from what I have in this book, because I'm not having calculator on me. This, of course, will give us exactly 4.5. 4.5. If you take the square root of this 4.5 to get s, say therefore, your s alone is going to be square root of 4.5, which gives you automatically 2.123. 2.123. It will give you this value. Okay? So this becomes the value of my variance. I did it because of what I have here, because this variance here, this standard deviation here is going to be raised to power 3. So this quantity is what I'm going to raise to power what? 3 there. So I now come again, because here is raised to power 3. I quickly come here and have what? F into x minus x bar, all raised to power 3. I'll have this. So and I have this. So what I'm going to do here is, this my x minus x bar has given me to be minus 2. Okay? This minus 2 raised to power what? 3 will give me minus 8. Multiplied by this frequency, which is 2 here, will give me minus what? 16. So I have here to be minus 16. Here, I have minus 1. Minus 1 raised to power 3 will equally give me minus 1. Minus 1 times this 1 here will give me minus 1. Here is 0. Everything here has to give me 0. Here is my 1. 1 raised to power 3 is 1. Multiplied by this frequency 1 will give me 1. Here is my 2. 2 raised to power 3 will give me 8. Multiplied by this 2 here now will give me 16. So I have what? 16. And when you sum everything here, it is going to give you what? 0 quickly. When it gives you 0, you now rejoice. Please permit me to clean this data here so that we can then finish the illustration here. So I will now clean this place, and clean up to this point. Remember, our interest is to find the measure of skewness, which is SK. So we have that our SK is equals. The formula is what we have here. The entire numerator is what we have here. Let me call the formula up here, sum over the range of x of f of x minus x bar all raised to power 3 all over n minus 1 multiplied by s raised to power 3. This is equals to, the whole numerator has given us 0. So we have 0 all over 5 minus 1, then multiplied by, my standard deviation s is 2.1213. So I have 2.1213 all raised to power 3. And because the numerator is 0 already, if you divide anything, if one numerator is what is 0, divided by anything is equally going to give you 0. So this will now give you what? 0. We have seen that the measure of skewness here is what is 0. That's what we have seen. And we said earlier that when the measure of skewness is 0, there is a condition, and that condition is that the mean, the mode, and the median of the data set or of the distribution are equal or approximately equal. Let us try to look at that to know whether what we said earlier is true with this data set we have here on the board. Permit me to clean this formula. Permit me to clean this formula. Remember that we had earlier that our mean is x bar. We calculated it to be 3. So I have that my mean, I have here already that my mean is equals to what? 3. Then let us now come to this observation now to go and get our mode. Our mode is defined as the data with the highest frequency or with the highest occurrence. So let us come. This data 1 here occurred only 2 times. These 2 occurred 1 time. This 3 here occurred 3 times. And if you look at the column of the frequency, this 3 is the highest. Then we ask ourselves, what is this observation that has this highest occurrence? The observation is what is 3. So I will now say that my mode is equal to what? 3 as well. So when I talk about the median is defined as the central value when you must have sorted your data in order of their magnitudes, either in ascending order of the values or in a descending order of their values. Once you sort them, the central value is what we call the median. If you watch here, of course, we have sorted this thing already in ascending order of their values. And then this our sum of n is what is 9, which is not an even number, it's an odd number. And we have in statistics what we call median locator. The median locator is given as median locator is given as sum of f all over 2, or is given as sum of f plus 1 all over what? 2. It is f over 2 when the sum of the observation is even. It is sum of f plus 1 all over 2 when the sum of the observation is what is a sum of the occurrence of the observation is what is a odd. When I sum the frequencies here, I got 9. 9 is an odd number, not an even number. So I'm going to use the second median locator. That second median locator will say sum of f plus 1, which is 9 plus 1. 9 plus 1 will give me what? 10. 10 divided by 2 will give me what? 5. So the locator of the median is 5. Not that the median is 5, the locator. Then I will now come here and ask myself a question. Is this 5 found in 2? No. 2 plus 1 is what? Is 3. Is 5 found in 3? No. 3 plus 3 is what? Is 6. Is 5 found in 6? Yes. 5 is found in what? In 6. Then we shift our hand here. We find out that the median is what? Is 3. So we now say that median is equal to 3. Don't you see that in this data set? The median is 3, the mean is 3, and the mode is 3, which actually agrees on the reason why, after calculating our skewness, we had that the skewness gave us what? Zero. When the skewness is zero, the mean, the median, and the mode are either equal or approximately equal to each other. So this is actually the much that we want to let you know about the measure of a skewness. In our next class, we are going to look at other ways to calculate measures of skewness, which actually we call the coefficient of skewness. The ones propounded by Pearson, coefficient of skewness, and the one propounded by Bowley's coefficient of skewness. In our next class, we are going to see how we can go about getting the value of our skewness now from the angles of those two persons. Thank you very much. Don't forget to subscribe to our YouTube channel, as we are making sincere efforts to making sure that you know statistics from the remotest part of the place where you are. Thank you very much, and stay tuned to our next class. If you have a challenge, please comment in the comment section. Once I come across it, I will come to your rescue. And then don't forget to subscribe and like our videos. Thank you very much.